Good morning and welcome to this lecture on PN Junction diode. I'm Akhilandeshwari, a faculty from Indian Institute of Information Technology, Tiruchirappalli, and I would like to introduce my team members, Ms. M. Anita and Ms. G. Jansi Rani, faculties from Indian Institute of Information, Tiruchirappalli. In this lecture, we will discuss in deep about the PN junction. Right. So, the outline of this lecture is Introduction to PN junction. What is meant by PN junction? How it is formed, that is formation of PN junction. What happens when you place a PN junction in an equilibrium, biasing of an PN junction, and the VI characteristics of PN junction diode. Now let us see what is meant by this PN junction. All of us know that all electronic components available today are made up of semiconductor materials. So these semiconductor materials they conduct electrons when they are placed either in high temperature or when external impurities are added to it. The process of adding impurities to the semiconductors are called as doping of semiconductors. Based on the dopant atoms, these semiconductors are classified as P-type semiconductors or N-type extrinsic semiconductors. Now, what is meant by this P-type material or N-type material? We'll discuss that. Now, when in pentavalent impurities, that is elements or the electrons, elements from group 5 from the periodic table or doped with the semiconductors, then an N-type extrinsic semiconductors are formed. These N-type materials have extra valence electrons in their valence shell. So the number of electrons is more than the number of holes in the N-type materials. You could see in the picture, it is a silicon structure, that is +4. That atom denotes the silicon, and one extra pentavalent impurities, either it can be arsenic, antimony or phosphorus, is added to this diagram. This is just a 2D representation. So you could see, since it is a pentavalent, 5 electrons are there, so 1 electron is left as the free electrons. All right. Now, what is meant by this P-type semiconductor? Now, this P-type semiconductor, on the other hand, is the materials which are formed when in trivalent impurities, that is group 3 elements from the periodic table are doped into the semiconductor. So each of these trivalent impurities contribute to 1 electrons in the semiconductor structure, as it is shown in the diagram. So +3, it denotes the trivalent, and you could see this trivalent impurity, that is, it can be aluminium, boron or gallium. It has only 3 valence electrons. So you could see only 3 electrons in the diagram. So 1 space or 1 electron is missing. So this denotes a hole is contributed by this trivalent impurities. So we can say electrons are the charge carriers or the majority charge carriers in the N-type semiconductors, while the holes are the minority charge carriers in the P-type semiconductors. Now, what happens when these PN junctions are brought together? Now we will take a single piece of semiconductor, a silicon semiconductor, which is widely preferred, is taken. One side of it is doped with pentavalent impurities and the other side of it is doped with the trivalent impurities. When this piece of semiconductor is placed in the equilibrium, that is in the steady state, what happens? Okay, so due to the concentration gradient, the electrons from N side will move towards the P side, and of course the holes from the P side will move towards the N side. Now near the junction of P and N region, the holes and electrons will recombine and they will become as an immobile ions. So you could see they are marked as an ionized acceptors, and the other side it is denoted as the ionized donors. So pentavalent impurities, as they donate one electron, they are called as donors, and trivalent impurities, since they are missing one electron, they are called as an acceptor. So it is marked as an ionized donors and ionized acceptor, which are nothing but due to recombination of electrons and holes, and one side you have ionized or immobile acceptor, on the other side you have the ionized or immobile donor atoms in it. Now these immobile ions forms like in a brick wall between the P and N material, and this region is known as the space charge region or the depletion region, since it is depleted of free charge carriers. Since this depletion region act as a barrier for the free flow of charge carriers, it is also known as barrier potential. Now due to the electric field, or due to the difference in potential that is developed across this barrier junction, we call that as an barrier potential or junction potential or built-in potential. Right, so because of this barrier, the holes and electrons cannot flow freely across the junction. So we could say the current across the device is zero when you place PN junction in the equilibrium. Graphically we can represent this barrier potential or junction potential as a difference in the height of energy bands, that is between N side and P side of the barrier region or the space charge region. So the barrier potential is nothing but the energy band gap. Right. As a summary, in this video we have discussed about what is p-type material, what is n-type material, how a PN junction is formed, and what happens to PN junction when it is formed at the equilibrium. Now in the next lecture we will see how this PN junction can be biased and what is its VI characteristics. Thanks for watching this video. Have a great day.